In this video, we're going to focus on straight lines that are defined in the Cartesian coordinate system or the rectangular coordinate system. So straight lines can be horizontal, vertical, or we can have lines that go downward as it goes from left to right, or straight lines that go upward as it goes from left to right. A horizontal line is a line that is parallel to the x-axis and is y units above or below the x-axis. This particular horizontal line is 5 units above the x-axis and is defined as y equals 5. A vertical line is a line that is parallel to the y-axis and it's x units to the right or x units to the left of the y-axis. This particular vertical line that we have here is 2 units away from the y-axis, or 2 units to the right of y-axis. So it's defined as x equals positive 2. So before we talk about non-vertical and non-horizontal lines, let's first talk about slopes. The slope describes the steepness of the line, meaning it describes how a line deviates from the horizontal, or how a line angles away from the horizontal. It also describes the direction of the line. If the value of the slope is positive, then the line goes upward as it goes from left to right. If the value is negative, then the line goes downward as it goes from left to right. Alright, so the slope is usually denoted as m, and it's expressed mathematically as the change in the y values over the change in the x values. So if you have 2 points, say x sub 2, y sub 2, and x sub 1, y sub 1, then the ratio between the difference in the y values and the difference in the x values is the value of the slope. And you can also think of it as rise over run. Now, I mentioned earlier that the slope describes how a line deviates from the horizontal, or how a line angles away from the horizontal. In that regard, an angle measurement is generated. So let's say we have a line. Say we know this point. From this point, this is the rise, right? And this part here is the run. So between this line and the horizontal, an angle is generated. Let's say that's angle theta. So relative to angle theta, you have the opposite side, which is the rise, and the adjacent side, which is the run. So opposite over adjacent, the ratio between the opposite over adjacent side corresponds to the tangent value of angle theta. Since tangent theta equals rise over run, and rise over run is equal to m, or the slope, therefore the slope can also be expressed as tangent of theta, where theta is the angle between the line and the horizontal. Okay, so let's apply the concept of the slope to the lines that we have earlier. First, we have the horizontal line, y equal to 5. Let's say we specify 2 points. Say this one, 0.45, and this one 0.75. Let's solve for the slope. Formula for the slope is y2 minus y1 over x2 minus x1. Let's say 0.75 is our x2, y2, and 0.45 is x1, y1. Okay, so let's substitute the values. We have y2 is 5 minus y1, which is 5 also, and then divided by x2. x2 is 7, and then x1 is 4. So the slope in this case is equal to 0. 5 minus 5 is 0 divided by 3, so that's 0. So this is always the case for all horizontal lines. Now let's look at vertical lines. So we have x equals 2 as our example earlier. Let's say we have this point, that's 2, 1, and this point, 2, 5. And solving for the slope, let's say this point is our x2, y2, and this point is x1, y1. Substituting the values, we get what? So y sub 2 is 5, this one, minus y sub 1, which is 1, and then x sub 2, which is 2, minus x sub 1, which is 1. The result is 4 over 0, and it's undefined, right? And this is always the case for vertical lines. Next, let's take a look at this line. Let's choose 2 points, say this point, 0.21, and this point, 4.3. Solving for the slope, let's say this point is x2, y sub 2, and this one is x sub 1, y sub 1. Substituting the values, we get 3 minus 1 over 4 minus 2. So the slope is positive 1. Now, we have two ways to express positive 1. It's either positive 1 over positive 1 or negative 1 over negative 1. Either way, it results to positive 1, right? This is important because we can use either of the two expressions in order to trace the line, okay? So let's say we start at 0.43, okay? And then we use this expression for the slope. So we have positive 1 over positive 1. Remember that the slope is rise over run. So if the slope is positive 1 over positive 1, it means from 0.43, we go up 1 unit, and then we go to the right 1 unit. Because again, positive, positive. So 1 unit upward, then 1 unit to the right. 1 unit upward, 1 unit to the right, 1 unit upward, 1 unit to the right. Okay, so this is for positive 1 over positive 1. Now, if you use negative 1 over negative 1, starting from the same point, 4, 3, negative meaning we go down 1 unit, and then we go to the left 1 unit also. So go down 1 unit, go to the left 1 unit, go down 1 unit, go to the left 1 unit. Okay. Now, how about this line? We expect that the slope of this line is negative because it's going downward as it goes from left to right. Say we choose 2 points, 4, 6, and 6, 3. Solving for the slope. Okay, let's say this is our x2, y2, and this is x1, y1. Substituting the values, you get 3 minus 6 over 6 minus 4, and it results to negative 3 over 2. So again, we have two ways to express negative 3 over 2. It's either it's negative 3 over positive 2 or positive 3 over negative 2. So to trace the line, say from point 63, we go 3 units downward. So 3 units. 1, 2, then 3. And then since it's positive 2, then we go 2 units to the right. So 1 and then 2. Okay. Or again from point 63, we can go 3 units up. So go up 3 units. 1, 2, 3. And then negative 2, we go to the left 2 units. So 1 and 2. Alright, so that's how we interpret the value of the slope of the line. Next, let's talk about equations of lines. So first, we have the general form. It is expressed as ax plus by plus c equals 0, where a, b, and c are constants. It can also be expressed as ax plus by equals c. Next, we have the slope-intercept form. It is written as y equals mx plus b. So it's called slope-intercept because it involves the slope of the line and in this case the y-intercept. So m for the slope, b denotes the y-intercept. So we have here the term intercept. Intercept or intercepts, these are points where the line or any curve crosses the x-axis if it's the x-intercept or the y-axis if it's the y-intercept. Okay, so for example, let's say we have a line that looks like this one. This line crosses the y-axis at this point. This is the y-intercept. Okay, so the ordered pair is 0, the x-coordinate is 0, and the y is any y value, say b. Okay, and then it crosses the x-axis at this point, so this is now the x-intercept. Okay, and its ordered pair is any x value and y is 0. Next, we have the point slope form. This is given by y minus y1 equals m times the quantity x minus x sub 1. So for this form of the equation of the line, we need a point, so 1 point, 1 ordered pair, and also the slope, right? So m for the slope, and then again we need 1 point or 1 ordered pair for us to define the equation of the line using the point slope form. Okay. Next, we have the intercept form. This equation focuses on the x-intercept and the y-intercept, and it's defined as x over a plus y over b equals 1, where a is the x-intercept and b is the y-intercept. Okay, so before we solve some problems, let's talk about the concept of parallel lines and perpendicular lines. So if two lines are parallel, let's say line A and line B, which are parallel, then they have the same slope. So mathematically, that's m sub a equals m sub b. On the other hand, if two lines are perpendicular with each other, let's say we have these two lines, line A and line B, which are perpendicular to each other, then the slope of line A is equal to negative the reciprocal of the slope of line B. Negative because if you look at the two lines, line B has a positive slope while line A has a negative slope. So it follows that the slope of one is negative the slope of the other. And then it's reciprocal because the rise of line A is the run of line B, while the run of line A is now the rise of line B. Okay, so let us now solve some problems. So problem number 1, find the equation of the line that passes through negative 1, 2, and with a slope of 4/3. Alright, so we are given a point and the slope. In that case, we can use the point slope form of the equation, which is defined as y minus y sub 1 equals m, which is the slope, times the quantity x minus x sub 1. So let's plug in the values. Y minus y sub 1 in this case is 2, equals m, where m is 4/3, times the quantity x minus x sub 1. X sub 1 in this case is negative 1, so negative times negative, it becomes positive 1. Okay. So depending on what is required in the problem, since it's not specifically stated if it wants an explicit form of the equation or implicit form of the equation or the general form of the equation, then we can express it explicitly or we can express it implicitly using the general form, right? So let's try the explicit form first. What we want in the explicit form is that we want to isolate y on one side of the equation. Okay, so y equals 4/3 times x, that's 4/3 x plus 4/3 times 1, so we have 4/3, and then transpose negative 2, so that it becomes positive 2. The equation now, y equals 4/3 x plus 4/3 plus 2, 3 times 2 is 6, 6 plus 4 is 10. This is now the equation of the line that passes through negative 1, 2, and with a slope of 4/3. Okay, or we can express the equation in its general form, right? So from here we can multiply both sides by 3 so that we get what? 3y minus 6 equals, so what we'll be left with in the right side is 4 times the quantity x plus 1. If we distribute 4, we get 4x plus 4. Okay, so converting this equation into the general form of the equation of the line, get 4x, right? Then transpose 3y, so it becomes negative 3y. Then transpose negative 6, so positive 6 plus 4, we get positive 10 equals 0. Okay? Alright, so we can check using a graphing tool or a graphing calculator, and if we graph the line, it looks like this one. So let's see if it really passes through negative 1, 2. So where's negative 1, 2? So this is negative 1, then 2 units up. So we have here negative 1, 2. And then let's check if the slope is indeed 4/3. Now, since the slope is 4/3, it can be expressed as positive 4 over positive 3. or negative 4 over negative 3. Either way, it results to, or it's equivalent to 4 over 3. Okay, so from point -1, 2, we can go up 4 units and then go to the right 3 units, or we can go down 4 units and then go to the left 3 units. So let's say we go downward 4 units, 1, 2, 3, and then 4, and then go to the left 3 units, 1, 2, and then 3. Right? So it's the same way. For example, if we start at this point, we go 4 units upward if we use this expression for the slope. So we have 1, 2, 3, and then 4, and then go 3 units to the right, 1, 2, and then 3. Okay, so therefore our answer is correct. Okay, so next problem. Find the equation of the line passing through the points 2, 3 and 3, -1. Alright, so we have 2 points. We can solve for the slope first, and then we can use the point slope form of the equation of the line to solve for the equation of the line. Okay, so let's solve for the slope. So we have y2 minus y1 over x2 minus x1. Let's say the point 2, 3 is our x2, y2, and then 3, -1 is x1, y1. Okay, so y sub 2 is 3 minus y sub 1. Y sub 1 in this case is -1. So minus -1 becomes +1, and then x sub 2. X sub 2 is 2 minus x sub 1. X sub 1 is 3. So our slope is what? 3 plus 1, that's 4. And then 2 minus 3, that's -1. Okay. Therefore, our slope is -4. Now for the equation of the line, we can use the point slope form. Okay, so y minus y sub 1, you can use either 2, 3 or 3, -1. Let's say we use 3, -1. So y minus -1 equals m, or the slope, that's equal to -4, x minus x sub 1. So x minus x sub 1 in this case is 3. So we get what? Y plus 1 equals -4x plus 12. Isolating y, we get, this is x, so -4x plus 11. Okay, so this is another equation of the line that passes through the points 2, 3 and 3, -1. Okay, if we trace this line using a graphing calculator, then it looks like this one. Okay, let's check if it really passes through the points 2, 3 and 3, -1. So we have 2, 3, 2, and then 3. Okay, so check. And then 3, -1. So we have 3 units to the right, and then 1 unit downward to this one. So check. Alright. Next problem. Find the equation of the line that passes through 1, 1 and is parallel to the line 2x minus 4y plus 3 equals 0. Okay, so recall that when two lines are parallel with each other, then their slopes are the same. Okay, so what we can get from this line is its slope, and the value of its slope is the same as the slope of the unknown line, right? So we have 2x minus 4y plus 3. This is in general form, right? So we first have to transform this equation into the slope-intercept form so we can easily identify the slope. Okay, so if we isolate 4y, you get 4y equal to 2x plus 3. And then divide both sides by 4. So 2 divided by 4, that's 1/2 x plus 3 over 4. This is now in the form y equals mx plus b, or the slope-intercept form. Therefore, the slope is equal to 1/2. This is also the slope of the unknown line that we want to find. Okay, so using the point slope form, y minus y sub 1 equals m x minus x sub 1. So for the unknown line, y sub 1 is 1 equals the slope is equal to 1/2, again because it's parallel to this line. Okay, so they have the same slope, times x minus x sub 1. X sub 1 in this case is 1. Alright, so we can isolate y. 1/2 times x, that's 1/2 x. 1/2 times -1, that's -1/2. And then transpose -1 to the right side, so it becomes +1. So plus 1. Therefore, the equation of the line now is equal to 1/2 x plus 1/2. Okay. Again, we can express this equation in its general form, ax plus by plus c equals 0, right? So let's start at this line, multiply both sides by 2. So this equation will become what? 2y minus 2 equals x minus 1. Okay, and then rearranging, we get what? X minus 2y, and then minus 2 transposed to the other side, so plus 2, and then minus 1, so that's +1 equals 0. Okay, so if we plug in this equation in a graphing calculator, also this equation, then we get these lines. Alright, so the orange one, that's for 2x minus 4y plus 3, and then the other one is 4x minus 2y plus 1 equals 0. And as you can see, they are parallel with each other. Next, find the equation of the line that passes through 2, -1 and is perpendicular to the line 3x minus y minus 6 equals 0. So this time, we will be dealing with perpendicular lines. Okay, so let's start by taking this line, 3x minus y minus 6 equals 0. This is in general form, right? So we have to convert this equation into the slope-intercept form. Okay, y equals mx plus b. So let's isolate y. We get what? Y equals 3x minus 6. Okay, so this is now in the form y equals mx plus b, where the slope is 3. Okay, so this is the slope of this line. Okay, and we want the equation of the line that is perpendicular to this line, right? So if the slope of this line is 3, then the slope of the unknown line, let's call the slope of the unknown line as m sub p, for example. It's equivalent to negative the reciprocal of the slope of this line, which is 3, so that's negative 1 over 3. Okay, and then using the point slope form, y minus y sub 1 equals m, in this case m sub p, times the quantity x minus x sub 1. Okay, so let's plug in the values. Y minus y sub 1. Y sub 1 in this case is what? Negative 1. So negative 1 equals m sub p, that's negative 1/3. And then x minus x sub 1. X sub 1 is 2. Okay, so we have y plus 1 equals distributing negative 1/3, negative 1/3 x plus 2/3. And then if we isolate y, we get y equals negative 1/3 x plus 2/3 minus 1. Okay, so y is equal to what? Negative 1/3 x plus or minus 1/3. Alright, or we can express the equation in general form. Okay, let's say we start at this point, multiply both sides by 3, we'll get what? 3y plus 3 equals negative x plus 2. Okay, so what we want is the general form of the equation, ax plus by plus c, right? So we can transpose negative x to the other side to become positive x plus 3y, and then transpose positive 2, so positive 3 minus 2, that's positive 1 equals 0. Okay, alright, so if we graph this equation and this equation using a graphing calculator, then we get these lines. Alright, so the orange line, this is 3x minus y minus 6. This is the given line. Okay, and the unknown line that we solved is the blue line. So x plus 3y plus 1 equals 0. And as you can see, they are perpendicular with each other. Right? And then let's check if the blue line really passes through the point 2, negative 1. So we have 2 and then negative 1. Check. Okay, last problem. Find the equation of the line that passes through 1, 2 and makes an angle of 45 degrees with the x-axis. Okay, so the unknown line that we have here, according to the problem, makes a 45-degree angle with the x-axis. Let's say this is the x-axis, this is our line. Okay, and the angle between them is 45 degrees. Okay, recall that the slope is also equal to tangent theta, where theta is the angle between the line and any horizontal line, in this case the x-axis. Okay, so if we plug in 45 degrees, which is a special angle, so tangent 45 means you have to take the ratio between sine 45 and cosine 45. Okay, and for 45-degree angle in the unit circle, the sine value is the same as the cosine value, therefore the ratio is equal to 1, right? Or tangent 45 is equal to 1. So the slope is equal to 1. So solving for the equation of the line using the point slope form of the equation, y minus y sub 1 equals m x minus x sub 1. Let's plug in the values. Y minus y sub 1 in this case is 2 equals m, which is the slope, and it's equal to 1. So this is 1 times x minus x sub 1, in this case 1. Alright, isolating y, we get y equals x transpose negative 2 to the right side, so it will become positive 2 minus 1, so that's positive 1. This is now our equation. Okay, so if we graph the equation, so this is the graph, and according to the problem, the line makes an angle of 45 degrees with the x-axis. So this is 45 degrees. How do we know this is 45 degrees? As you can see, the line divides the square into two equal parts, right? So this is 90 degrees all in all, divided by 2, so 45 degrees. And it's exactly 1 unit up and then 1 unit to the right, okay, meaning the slope is 1.